Hi guys, this is Mohammad P, a tutor on Chegg.com. Today I'm going to talk about implicit differentiation. The main difference between the regular derivatives and implicit differentiation is that the y, which is a dependent variable or the function, is not given explicitly in terms of x. So in regular differentiation, you have y on one side and all this stuff in terms of x on the other side. So you can just say y prime equal taking the derivative on whatever is on the right. But as you see on the board, we have an expression which is involved with all x and y and combined together. So we are going to find y prime, which is dy dx. It's still the same thing, just the way to approach this, we need to start taking the derivative of each single piece, and when we get to the y, we need to apply the chain rule, which says that take the derivative of inner function, the derivative of inside of y, which is dy dx, and we should multiply it by the derivative of y. So as you see in this case, the y is not given explicitly in terms of x. They're all combined. So let's just start taking the derivative of the first term, which is going to be 2x. And then I get to negative 4xy. So here x is being multiplied by y, so we need to use product rule. So to use the product rule, I need to take, I keep the negative 4, which is a constant outside. So the derivative of the first piece is dx dx, the derivative of x respect to x, which is 1, obviously, times the second part, which is y, plus the first part, which is x, times the derivative of the second part, which is dy dx. So I get to the next part, that's going to be product rule again, because e to the x is being multiplied to y. So the derivative of the first thing is d dx of e to the x times the second part y, plus e to the x times the derivative of the second part, which is dy dx. And then when we get to the 10, that's going to be 0 because it's a constant. And then sine y, the derivative of that is going to be cosine y, times, here is the chain rule, the derivative of inside, which is dy dx. Okay, so dx dx is 1, and the derivative of e to the x is going to be e to the x. So I'm going to simplify this a little bit. So I have 2x minus 4 times this is negative 4y minus 4x dy dx, and then I have plus e to the xy plus e to the x dy dx equal cosine y dy dx. Okay. Now I'm going to take everything which has dy dx to one side and keep the other one on the left. So I keep 2x minus 4y plus e to the xy on the left, and I take 4x dy dx to the right, so it becomes positive like this, and e to the x dy dx becomes negative. And then I have cosine y dy dx on the right. Okay. Now, so we are trying to solve for dy dx, and here we are gonna take dy dx out on the right side. So on the right side we have okay, let me rewrite the left side, 2x minus 4y plus e to the xy. I factor out dy dx on the right, so I get 4x minus e to the x plus cosine y. And since we are solving for the dy dx, we are finding the derivative, so I'm gonna divide both sides by 4x minus e to the x plus cosine y. So dy dx is going to be 2x minus 4y plus e to the x y, and then divided by 4x minus e to the x plus cosine y. Okay, so that's basically it. So as you see, we started to take the derivative from each single term. The terms that they were combined of x and y, we used the rule. So in this case, we used product rule. You might actually use quotient rule, chain rule, or whatever it's used in the regular differentiation. And the goal is to put the terms with the dy dx together and factor it out and finally solve for dy dx, which is the derivative of of y with respect to x. I hope all of you enjoyed and you understood as much as I explained. So till next video, I hope you the best and have a good one. Bye.